Hi, this is part 2 of Arithmetic Sequences 9.2, and on these problems, they all come out of the same section of 9.2, and this is when arithmetic sequence is given to you, and you have to find the common difference and the first four terms. Now, remember, to find the first four terms, you just plug in 1, 2, 3, and 4 into the end, and those are your first four terms. And you can identify the slope a couple of ways. Well, it is a slope, but identify the common difference in a couple of ways. You could actually put the first four terms down and then subtract the second term minus the first term. You can do it that way, but if it's also linear in form, remember it's also the slope. So in this case right here, I can tell you right off the bat that the common difference is 5 because the slope is 5. And on this one, the common difference is going to be negative 1/2. Now I do want to draw your attention to the labeling of this. A sub n, B sub n, C sub n. Just like back in 9.1, all sequences are not just labeled A sub n. They can call it any label they want, just like functions were sometimes alpha of x, and sometimes they were g of x, and sometimes they were h of x. So it is not always A sub n. And for you guys who haven't been in class for a few days, these little subscripts represent the terms you're looking for. So A sub 1 is the first term. A sub 2 is the second term. So like I said, like this one's A sub 1, A sub 2, A sub 3, A sub 4. So now A sub 1 represents the first term. To find the first term, you plug 1 in. So this is no different really than evaluating the functions. If you remember functions when we were evaluating them, you guys liked those because all it amounted to was just plugging a number into a variable x. Well, in this case, you're plugging a number into the variable n. So it's the same idea actually. That's why I called before sequences are just functions written in a little different way. And but anyway, so you just plug in 1, 2, 3, and 4, and that defines the first four terms. So if you plug in 1, 5 times 1 minus 6, that's negative 1. And then A sub 2 is 5 times 2 minus 6, that's 10 minus 6, which is 4. And then the third term is 5 times 3 minus 6, which is 9, 15 minus 6. And then 5 times 4, which is 20, and then 20 minus 6 is 14. Now I want you to notice something, that this is an increment of 5. You add 5 to 4, you get 9. If you add 5 to 9, you get 14. So the common difference is 5. But I want you to notice that is the slope of that. So if you don't remember that the common difference is this number in front, so this is when the formula is given to you. So, and remember, this is linear, this one's linear, so they are arithmetic. Now, if you look over here at example 3, it doesn't look linear, but it is. When I get to that, I'll show you what you have to do to that. So this one is the first four terms, and the common difference is 5. And like I said, if you don't understand that that number is going to be your common difference, you can just take any two terms, subtract them consecutively. So you get 14 minus 9, or 9 minus 4, or 4 minus a negative 1, which is a little bit more difficult. But either way, you get 5. So that's example 1. Example 2, okay, same idea. First term, and this is actually B, so it's B sub 1, B sub 2, B sub 3, B sub 4. So you plug in 1, so it'd be negative 1/2 times 1 plus 10. And I believe that's going to be negative 1/2 plus 20 over 2, which is 10. And if you wonder why I'm making it over 2, is because I want to get a common denominator. And that's going to be 19 over 2, or 9.5 if you prefer. And then the next one's going to be negative 1/2 times 2, because it's the second term, plus 10. And that's going to be negative 1 plus 10, and that's actually going to be 9. Remember, this was 9.5, now this one's 9. So it's going down by 1/2, which might make sense because that's the common difference. It's negative 1/2, because it's the number in front of the n. So the next one's going to be negative 1/2 times 3 plus 10, and that's going to be negative 3 over 2. And then 10 again is still 20 over 2. And then that's going to end up being 17 over 2. Now 17 over 2 is 8.5. So let's see. 9.5, 9, now 8.5. So what do you think the next one's going to be? If you said 8, you got it. Yeah, so it's going to be negative 1/2 times 4 plus 10, and that's negative 2 plus 10, and that is indeed 8. So it is going down by 1/2 every time. But I knew that to begin with because that's what the slope was. It's negative 1/2. So once I found that first term to be 9.5, and I know that d was going to be negative 1/2, I could have just went from here to here to here to here real fast. So if I asked for the 5th term, you probably could tell me right now. So yeah, the 5th term is actually going to be 7.5, or 15/2 if you want to write it that way. Anyway, the common difference here is negative 1/2. And then on example 3, it doesn't look linear, so therefore it doesn't look like it's arithmetic, but it is. But you got to remember one of your rules of logarithms. It's one of your properties. Remember, it was e to the natural log of x was x, but also the natural log of e to the x is x, which is the one I'm using here. So the natural log of e to the 3n plus 4 is the same thing as 3n plus 4. So c of n is the same thing as 3n plus 4. Now they gave you a couple of problems in your homework, and that's why I'm doing this one that has something like example 3, and that's why I'm doing it. And it's just a trick. They're just trying to trick you into believing that this is not arithmetic. So you got to use a little bit of your logarithms to break it down to what you can, and you'll notice that it is linear. Because you got to remember, these are arithmetic. And if they're arithmetic, they're all linear. So now you do the same thing, C of 1, C of 2, C of 3, C of 4, and you could probably see, well, I'm looking for the common difference as well, and if you look at the slope, it's 3. So now watch this. I'm going to show you another way to do this problem. Find the first term, which is plug 1 in. 3 times 1 is 3, plus 4 is 7. So that's the first term. Since I know the difference is 3, the gap between the numbers is 3, I know the next number has to be 10, the next number has to be 13, and the next number has to be 16. So I was able to find the next 3 numbers based on the first term and the common difference. And sure enough, if you plug 4 in, 3 times 4 is 12, and then 12 plus 4 does give me 16. The only problem doing it that way is if you miss the first term or if you miss the common difference, well, you miss the common difference, you're probably going to miss it anyway. But if you find the second term, third term, and the fourth term that way, if you miss one of the first term or the common difference, you're probably going to miss the next 3 terms as well. So if you want to be a little safer, you can just plug in 1, plug in 2, plug in 3, plug in 4. And that way, if you miss one, it won't make you miss everything else. So in other words, it'd be independent of each other. And if you find the C2, C3, C4 based on C1, it's dependent on whether you got C1 right or not. So, okay. So this is example 1, 2, and 3. This is when the sequence is given to you. What is the first 4 terms and what is the common difference? So that concludes part 2 of section 9.2. We got 3 more to go.